In this video, we will explore about solving trigonometric equations. So let us start by having review concepts. So these review concepts are the concepts that we're going to use in solving trigonometric equation. So the first is trigonometric function values of quadrantal angles. When you say quadrantal angles, these are angles whose terminal side lies on the axis. So they are 0 or 2 pi, then 90 degrees or pi over 2, 180 degrees or pi, 270 degrees or 3 pi over 2, or 2 pi or 360 degrees. So here we have a unit circle. When you see a unit circle, the radius is 1. And for example, this one is radius. So this is also radius, 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 and also radius. And all the values of this radius is equal to 1. So that's why, so this is radius, so this point is 1, 0. So this point is radius 1, so this point is 0, 1. Radius 1, so this point is negative 1, 0 because it's on the left of the origin. And this radius is also 1, so this point is 0, negative 1. So here, in any point of this unit circle, the x value represents the cosine of the angle, and the y value represents the sine of the angle. So that's why this 1, 0, this means the cosine 0 is 1 and the sine 0 is 0. And for example, this 0, negative 1, the cosine 3 pi over 2 is 0 and the sine 3 pi over 2 is negative 1. So the point here is that if the sine value or cosine value is either 0, 1, or a minus 1, you know that the angles are quadrantal angles. Because I know that you can use calculator in finding for the angle. So that is the point for this. So I want you to be aware on those values. So let us have another. When the angle is an acute angle. So in pi over 6, the cosine value is square root of 3 over 2 and the sine is 1/2. While in pi over 3 or 60 degrees, the cosine is 1/2 and the sine is square root of 3 over 2. So they have the same values here, they just interchange the coordinates. And then for pi over 4, the sine value is equal to the cosine value, which is square root of 2 over 2. So I know that you can use calculator in finding the angle for this cosine and sine, but the point here again is the sine, if the sine value and cosine value is either square root of 3 over 2 or 1/2 or square root of 2 over 2, you know that the angle is acute angle. So meaning when the angle is an acute angle, so we can find, or that is also equal to the reference angle. But if the angle is quadrantal, we do not need to find for the reference angle because the reference angle should always be acute. So in summary, as I told you, if the sine and cosine is either 0, 1, or negative 1, the angle is quadrantal. If the sine or cosine is either square root of 3 over 2, 1/2, or square root of 2 over 2, the angle is an acute angle, and that acute angle is the reference angle. The next concept that we'll be using here are the signs of trigonometric functions. So you can use the ASTC, or add sugar to coffee, or all students take chocolate. So A stands for all functions of trigonometric functions here are positive. And then on the second quadrant, S stands for sine and its reciprocal cosecants are the only positive here, the rest are negative. And then on the third quadrant stands for T, which is tangent, and its reciprocal, which is cotangent, are the only positive in this quadrant, the rest are negative. And then for the fourth quadrant, which is C, stands for cosine, and its reciprocal secants are the only positive here, and then the rest negative. And then the next basic concept is finding the angle when reference angle is given. So in finding the angle, so we can have an example on the next slide. For example, the given reference angle is pi over 4, which is located here, and we want to find this angle measure in standard position, which is theta. So we can find for theta, since theta is less than pi, so we can find this measure as subtracting the theta in the pi radian. So theta is pi minus pi over 4, which will give us 3 pi over 4. Another example is, let's say the reference angle is pi over 3. So this is the location of reference angle, and we're looking for this angle theta here. So we can find for the angle theta by adding this reference angle to pi because it's more than pi. So the theta is pi plus pi over 3. Then the next angle is, let's say the reference angle is pi over 6 and it's located here, and we want to get the measure of this angle theta over there. So we can find that since this is less than 2 pi, so we can get the angle theta by subtracting pi over 6 to 2 pi. So it will give us 11 pi over 6. So you can just make use of this formula. So just to give you an overview about how you are solving a trigonometric equation, so let's start with this. In finding the value of trigonometric function, like what is cosine pi over 6? So if you will use calculator, make sure your calculator is in radian mode because you need to enter the pi. So cosine of pi over 6, it will give us square root of 3 over 2. So this is finding the trigonometric function value. But in solving trigonometric equation, it means we need to find the angle, this angle, whose value of the function is given. So it's the opposite. So before, we're looking for the cosine of pi over 6, which is square root of 3 over 2. So this time, in solving trigonometric equation, this pi over 6 is the unknown, meaning the angle is unknown. So for example, cosine theta is equal to square root of 3 over 2. So what is theta? So this is solving trigonometric equation. So to solve for theta, so we know that theta is pi over 6. So in calculator, you will press inverse cosine square root of 3 over 2, and it will give us pi over 6. In this example, we will find all the solutions of each trigonometric equation, or finding the general formula. So in solving trigonometric equation, we're going to solve for the unknown angle. So not only one angle, not only two angles, but infinitely many. So when we find for the angle theta, so we need to find its coterminal. So cosine theta plus 1/2 is equal to 1. And what we're going to do here is to isolate first the trigonometric function, which is cosine theta. So we're going to move 1/2 on the other side. So it will give us cosine theta is equal to 1 minus 1/2. Then 1 minus 1/2 is equal to 1/2. So the equation will give us cosine theta is equal to 1/2. Then once you isolated the trigonometric function, so the next step is to find its reference angle. Because if you will press this in calculator, pressing inverse cosine or shift cosine 1/2, it will give you only one angle. But the solution can be one, can be two angles, can be infinitely many. So what we're going to do here is, instead of putting this in calculator, we're going to find for the reference angle. And the reference angle is shift cosine or inverse cosine of the absolute value of 1/2. So you will always get the absolute value of any value here. So now you're going to use calculator to find this, and you will put your calculator in the radian mode. So enter shift cosine positive 1/2, which will give us pi over 3. So you can check that in calculator. Then you will use this reference angle to find the error angle. So how? So first, let us draw the rectangular Cartesian plane with signs of the trigonometric function, because we need to know in which quadrant where the cosine theta is a positive. It is positive in the first quadrant and in the fourth quadrant. So in the first quadrant, the angle here, since this is acute, so that is the reference angle, because when the angle theta is in the first quadrant, it is equal to the reference angle. So the first angle here is pi over 3, so that is the first solution. Then the second angle, it will give us, since the angle is in fourth quadrant, it's less than 2 pi, So it will be 2 pi minus the reference angle, which is pi over 3. So you can see here that we use the idea or the value of the reference angle to find the two angles here. So on the first quadrant, it's pi over 3. And on the second quadrant, it's 2 pi minus pi over 3. And they are pi over 3 and 5 pi over 3. Now, these are only two solutions from 0 to 2 pi. What we want is all solutions, meaning we have to get the coterminal of this pi over 3 by adding 2 pi k in pi over 3, and in this 5 pi over 3 we will get again the coterminal for this. Remember, in getting the coterminal you will keep on adding 2 pi or subtracting 2 pi, so meaning we will add 2 pi k, where k is an element of integers. So k here can be 0, can be 1, -1, 2, -2. So all the angles here will be coterminal angle of pi over 3, and all the angles from k equal to 1 and so on will be the coterminal angles for 5 pi over 3. So these are the solutions that we want on this trigonometric equation. Then for the second equation, negative tangent x is equal to 1. So x here is the angle. So first, we have to isolate the trigonometric function, which is tangent x. Since it is multiplied by a -1, so we have to divide or multiply both sides with -1. So we will get tangent x is equal to -1. Then again, so we have to get the reference angle. The reference angle for this is inverse tan absolute value of -1, and if you will press this in calculator in gradient mode, it will give us pi over 4. So in this reference angle, we will use this to find the rest of the angles. So first, let us draw the Cartesian plane, and we have to find out where the tangent x is a negative number. So it is negative on the second quadrant and on the fourth quadrant. So on the second quadrant, since the angle here is less than pi, so the angle must be pi minus the reference angle, which is pi over 4. So pi minus pi over 4. And then on the fourth quadrant, since the angle here is less than 2 pi, so it's 2 pi minus the reference angle, which is 2 pi minus pi over 4. Now, to get the values of this angle, so pi minus pi over 4 is 3 pi over 4, and 2 pi minus pi over 4 is 7 pi over 4. And since we want all the solutions, so we will get the coterminal angle for these two angles. So we just keep on adding 2 pi k and another 2 pi k for 7 pi over 4, where k is an element of integers. And as you can see here, the first angle is in the second quadrant and the second angle is in the fourth quadrant. So it looks like it's only the opposite of this. If this is 3 pi over 4, if I would just keep on adding pi, I will get the second angle. Meaning, we can simplify these two equations into only one equation, which is equal to 3 pi over 4 plus pi k. Because from this 3 pi over 4, we can get another angle or the second angle by adding pi or subtracting pi. So that's why we can simplify these two equations into only one equation, 3 pi over 4 plus pi k, where k is an element of integers again. For the next example, we will solve the following equations in the given domain. So here we have 2 sine theta plus square root of 3 is equal to 0, where theta is between 0 to 2 pi. So this is different from the first example because in the first example, we ask all the solutions or the general formula. So meaning in those solutions, we have to get its coterminal angles. But here, the angle must be limited and the solution is only from 0 to 2 pi. So first, let's isolate again the trigonometric function, which is sine theta, by moving square root of 3 on the other side. So it will give us this equation. And then after that, since sine theta is multiplied by 2, so we have to divide both sides by 2. So we will get the equation sine theta is equal to negative square root of 3 over 2. Since the angle here is an acute angle, so we're going to find the reference angle again. So the reference angle of this is inverse sign or shift sign, absolute value of negative square root of 3 over 2. Take note, you will always get only the positive. So that's why we have to put an absolute value here before putting this in calculator. So in calculator in radian mode, so you have to enter shift sign, positive square root of 3 over 2, and it will give us pi over 3. So pi over 3 is the reference angle that we're going to use to find the remaining angle. So first, so let us draw this Cartesian plane, and let us see where is the sine theta as negative number. The sine theta is negative in quadrant 3 and a quadrant 4. So quadrant 3 and a quadrant 4. So let's find the angle in a quadrant 3. Since the angle is in quadrant 3, which is more than pi, so meaning this is pi plus the reference angle, which is pi plus pi over 3. And another angle is in fourth quadrant, since it's less than 2 pi, so the formula for to find this angle is 2 pi minus the reference angle, which is 2 pi minus pi over 3. So to find the theta, pi plus pi over 3 is equal to 4 pi over 3, and 2 pi minus pi over 3 is equal to 5 pi over 3. So these are the two solutions because these two angles are between 0 to 2 pi. So these are the only two angles in one rotation or one revolution, or 0 to 2 pi. So these are the solution set. For the next equation, so we have an equation for cosine squared theta minus 3 is equal to 0, wherein the theta must be from 0 to 2 pi again. 0 to 2 pi, or in just one revolution. So first, let us isolate cosine squared theta by moving negative 3 on the other side and dividing both sides by 4. So it will give us cosine squared theta is equal to 3 over 4. Then after that, we can get square root of both sides. So when we get square root of both sides, the left side will be cosine theta, and the other side will be square root of 3 over 4 with plus and a minus. So we will get cosine theta is equal to plus and minus square root of 3 over 2. Since we know that the angle here is an acute angle again, so let's get the reference angle. So the reference angle is the shift cosine or inverse cosine absolute value of this number. So once you press in calculator, make sure it is in radian mode, so you will enter shift cosine of positive square root of 3 over 2. So it will give us pi over 6. So this is the reference angle that we're going to use to find the rest of the angles. So first, let us draw the Cartesian plane again, and let's locate in which quadrant where the cosine theta is a positive and a negative. So we need a positive value and a negative value for cosine. So as we know, it's in the first quadrant, second quadrant, third quadrant, or in the fourth quadrant. So meaning in all quadrants. So first, second, third, and fourth. So let's find the angle one by one. So since the angle is in the first quadrant, the angle here is always equal to the reference angle, which is pi over 6. And then for the second angle in the second quadrant, since the angle is less than pi, so it should be pi minus the reference angle, which is pi over 6. And then for the third angle, which is in the third quadrant, since this is more than pi, so it should be pi plus the reference angle. And then in the fourth quadrant, since this is less than 2 pi, so it should be 2 pi minus the reference angle. Then let's just get all the angles here. So the theta is equal to first pi over 6, next is 5 pi over 6, sorry, and next is 7 pi over 6, and the last is 11 pi over 6. So these are the four angles in one revolution or one rotation, or from 0 up to 2 pi. So these four angles are the solution set for this equation. The next equation is 2 sine squared theta plus sine theta is equal to 1, where theta is from 0 to 2 pi, so meaning in one revolution. And here we can see that the equation is a quadratic equation because of the sine squared. So what we're going to do is, when we have a quadratic equation, always equate to 0 before factoring. So we're moving 1 on the left side and equate to 0. So this is the quadratic equation. Then let's start factoring by getting the factors of 2 sine squared theta. So to get the factors of 2 sine squared theta, so we have a 2 sine theta and a sine theta. And then the last term is -1, so either +1 and -1. So let us try putting -1 on the first factor, and then the other one is a +1. So we have to make sure that the product of this is equal to that before we continue. So let's check. 2 sine theta times sine theta is 2 sine squared theta. And then -1 times +1 is a -1. Then to check for the middle term, so we have to multiply the inner terms. -1 times sine is negative sine, and the outer terms, which is 2 sine theta. So the inner is negative sine theta, and then 2 sine theta is the outer terms. If we will add that, it's equal to sine theta. So that is correct. Then these two expressions will be equated to 0. So the first equation is 2 sine theta minus 1 equal to 0, and sine theta plus 1 equal to 0. So that is the zero product property. So let us try to solve first the first equation. 2 sine theta minus 1 equal to 0. So since this is a linear equation, we have to isolate the one trigonometric function, which is sine theta, by moving -1 on the other side and then dividing both sides by 2. So we will have sine theta is equal to 1/2. Then, since we know that the angle here is acute angle, so we find the reference angle again, which is shift sine or inverse sine absolute value of 1/2. Then press this in calculator in radian mode because our domain here is in radian mode. So we will get the angle which is pi/6. Then let us locate in which quadrant where the sign is positive, and we know that it's positive on the first quadrant and on the second quadrant. Now let us find the angles in these two quadrants. So since the angle is in the first quadrant, it is always equal to the reference angle, which is pi/6. And then for the second angle, since this is less than pi, so the formula for the angle here is pi minus the reference angle, which is pi minus pi/6. So computing these two angles, we will get the theta on the first equation, which is pi/6 and 5 pi/6. So let us move to the second equation. The second equation is sine theta plus 1 is equal to 0. So we move the positive 1 on the other side, so it will give us sine theta is equal to -1. Then do not find the reference angle here since the angle here is quadrantal angle. You can check that also in calculator. It will give you not an acute angle. It will be pi/2 or negative pi/2. So to find for the angle, so one option is if you remember this unit circle with points 1 0, 0 1, -1 0, and 0 -1. So you just need to locate the y value since sine is for the y value and cosine is for the x. The y value must be -1, and the y value which is -1 is when the angle is 270 degrees or 3 pi/2, meaning the angle here is 3 pi/2. Another way is if you really want to use the calculator, so what you're going to press is shift sign -1, and it will give you -pi/2. So that is what you will get in calculator. As I told you, do not find the reference angle because the angle here is quadrantal. So shift sign -1 is equal to -pi/2, but then -pi/2 is not from 0 to 2 pi. It is outside this domain because 0 to 2 pi is a positive angle, but this is a negative angle. So what you can do is to get the coterminal for this. So to get the coterminal, you would just add 2 pi in -pi/2 to get 3 pi/2. And this 3 pi/2 is inside this domain 0 to 2 pi. So this is how you will get the 3 pi/2, which is the value of the angle. So therefore, so we now have three values for the angle for this equation. First is pi/6, next is 5 pi/6, and the last is 3 pi/2. And this is a solution set of this equation. So the next equation is sine 2 theta is equal to 1/2, where theta is from -pi/2 to pi. Take note that The angle here in trigonometric equation is a double angle, and the domain here is a single angle theta. So before we continue, we have to make them the same. And to make the same angle, it's better to multiply the domain by 2 to have a 2 theta. So the new equation will give us into this. So same trigonometric equation, and the new domain, multiplying this by 2, it will give us negative pi less than or equal to 2 theta, which is less than 2 pi. So next, so since sine 2 theta is already isolated, so meaning we have to find the reference angle of the 2 theta. Take note, it's 2 theta, not theta. So the reference angle is the shift sine absolute value of 1/2, and if you will process in calculator, it will give you pi over 6. So we're going to use this reference angle to find the rest of the angle. So first, let us locate in which quadrant where the sine is positive. It is positive on the first and on the second quadrant. So if the angle is in the first quadrant, so the angle is equal to the reference angle, which is pi over 6. And if the angle is on the second quadrant, which is less than pi, so meaning the formula is pi minus the reference angle, which is pi minus pi over 6. So the theta here, the 2 theta is equal to pi over 6, and another angle is 5 pi over 6. So these two solutions are the angle solutions from 0 to 2 pi, or negative pi to 2 pi. Take note that these two solutions is from 2 theta. And since these two are the solutions from 0 to 2 pi, so next is we have to find also from negative pi to 0, or 0 to negative pi. We know that negative pi is a negative angle, meaning the direction is clockwise direction. And we can see here that 0 to negative pi, there is no angle solution we can find in the third quadrant and in the fourth, because the angle solution is only on the first and on the second quadrant, meaning there's no solution or angle solution that we can find from 0 to negative pi. So means the 2 theta is only equal to pi over 6 and 5 pi over 6. But take note, as we said, these two solutions are from negative pi to 2 pi and base from 2 theta or equal to 2 theta. But what we need is only for theta, where the domain is from negative pi over to pi. So what we're going to do here in these two solutions, which is equal to 2 theta, so we will multiply this by 1/2 to get the theta. So multiplying 2 theta by 1/2, it will give us the theta. And multiplying these two by 1/2, it will give us pi over 12. And another one is 5 pi over 12. So these two, we can verify that pi over 12 and 5 pi over 12 is from negative pi over 2 up to pi only. So this is the solution set for this equation. The next trigonometric equation is from the section exercise, which is 2 sine theta plus 1 is equal to negative 1, where theta is from 0 to 4 pi. When we say 0 to 4 pi, meaning the angle solution is from 2 revolutions. So not only 0 to 2 pi, but also up to 2 pi to 4 pi. So first, let us isolate the sine theta by moving 1 on the other side. If we will move 1 on the other side, it will give us the equation 2 sine theta is equal to negative 2. Then to isolate or to solve for sine theta, divide both sides by 2. So it will give us the equation sine theta is equal to negative 1. And take note, the angle here is not an acute angle, because when sine is negative 1 or negative positive 1 or 0, they are quadrantal angles. So means what you're going to do is do not find the reference angle, and what you can do is to find theta using calculator. So you can use shift sine negative 1, and it will give you negative pi over 2. And as we said, negative pi over 2 is not in this domain because this is positive angle, but this one is a negative angle. So what you can do is find the coterminal angle. So the coterminal angle for negative pi over 2 is add 2 pi, so it will give us 3 pi over 2. So it means the solution for this theta is 3 pi over 2. And take note, this 3 pi over 2 is only the solution or the angle solution from 0 to 2 pi, meaning only in one revolution. So on the other revolution, for the second revolution, you will add 2 pi again for the solution from 2 pi to 4 pi. So keep on adding 2 pi because our domain needs to be 0 to 4 pi, not only 0 to 2 pi. So add 2 pi in 3 pi over 2, it will give us 7 pi over 2. So these two are the angle solution from 0 to 4 pi. The solution for the interval 0 to 2 pi is 3 pi over 2, and the solution from 2 pi to 4 pi domain is 7 pi over 2. So these two are the solution sets. The next equation is from section exercise. 2 sine squared x plus 7 sine x is equal to negative 3, and the solution must come from 0 to 4 pi. So first, we have to identify whether the equation is a linear in form and quadratic in form. Since this is quadratic in form because of this sine squared x, so we have to equate to 0 before factoring. So to equate to 0, we will move negative 3 on the other side. So we will have this equation. And then after that, we can now start factoring. You can factor using quadratic formula, assuming that sine x is a variable y or a variable x, or you can use calculator, or you can use trial and error or guess the factors. So what I will do is I will get the factors of 2 sine squared x, which are 2 sine x and sine x, and then factors of positive 3, so 1 times 3. So I can put here plus 1, or I can put the other plus 3. Then make sure the factors are correct before you continue. So if you will check the first term, it's the product of 2 sine x and sine x, so that's the product of the first term. And then for the last term, the product of the last terms, which is 1 and 3. So 1 times 3 is equal to 3. And then for the middle term, you will get the product of the inner terms and product of the outer terms, then add them. So the inner terms, the product is sine x, and then plus 6 sine x is equal to 7 sine x. So these factors are correct. Then after that, you can use the zero product property by equating both of this to 0. So you will get 2 sine x plus 1 equal to 0 and sine x plus 3 equal to 0. Then let us solve the first equation. On the first equation, we have a linear form, and we will isolate the sine x by moving 1 on the other side and then dividing both sides by 2. So we will get sine x is equal to negative 1/2. And then since we know that the angle here is an acute angle, let's find first the reference angle. So it is shift sine, absolute value of 1/2, which is equal to pi over 6. Then we need to know in which quadrant where this sine theta is a negative. So it's a negative in the third quadrant and in the fourth quadrant. So we can now identify the angles here by using this reference angle. So the angle in the third quadrant is pi plus reference angle because the angle is more than pi. And then the angle in the fourth quadrant, since it's less than 2 pi, so it's 2 pi minus the reference angle. So we can just simplify these two angles. So the angle x is equal to 7 pi over 6, and another one is 11 pi over 6. These two angles are the angle solution from 0 to 2 pi or 1 revolution. But what we need in our domain is from 0 to 4 pi. So meaning we need in 2 revolutions. So we will be needing another 2 angle solutions by adding 2 pi in each. So if I will add 2 pi in 7 pi over 6, we will get 19 pi over 6. And adding 2 pi in 11 pi over 6, we will get 23 pi over 6. So these are the 4 angles from this equation from the domain 0 to 4 pi. So let's move on the second equation. The second equation is sine x plus 3 is equal to 0. And then, so we will isolate the sine x, so by moving 3 on the other side, so we will get sine x equal to negative 3. And then, you can see here that sine x equal to negative 3. We know that the range of the function sine x is from negative 1 to 1 only. So it means to say there is no angle in this equation. Or if you will use calculator, try to check shift sign -3 and it will appear a math error. So that means the solution set is only these four angles from this equation.